Hi everyone, welcome to MasterCAM, the complete course. I hope you are all doing well. So we are going to start the module number 4, which is all about the chaining and toolpath parameters. So what we are going to discuss in this module is all about the chaining basics and chaining options, basic toolpath workflow, toolpath type, tools and holders, general cutting parameters and linking parameters. So let me clear to you that in this module, the most important thing we know is all about the 3D toolpaths. It's not all about the 2D toolpaths. We are going to discuss 3D toolpaths. In the previous videos, we discussed how we can create 2D wireframe geometry. And after creating 2D wireframe geometry, we discuss how we can create 2D toolpaths for simple geometry. In the module number 3, we discuss how we can make 3D models using the MasterCAM. And further move in the module number 4, now we are going to discuss how we can create 3D toolpaths for the 3D models. So in this video, I'm going to give you an overview how we can create 3D toolpaths for our 3D models. So let's get started. So I'm using the MasterCAM 2023 version. You may use either 2022, 2023 or 2024. All these versions have almost the same GUI and there's a little updates in them. So don't worry about the version. So I'm using the 2023 version. You can either download from the official website. So let's do the 3D toolpaths. For that, you have to create 2D wireframe. So I'm going to create a simple geometry to give you an overview of how we can make 3D toolpaths for our 3D geometry. So let's get started and make a simple geometry using the wireframe tab. Go to rectangle. I'm going to create a rectangle and make it center. Click here. Just create a simple rectangle here. Height 100 and the width is 300. Okay. And what I'm going to do is I'm going to make it solid. So in this video tutorial, you can get to know how we can create 2D models. This is an overview video, okay? So click extrude, select the chain. As you know that we have to select the appropriate chain for that. So we have a wireframe model and this is a wireframe model. So click here, chain, okay. So it shows that it should make it upward direction. Let's make it in downward direction, okay? Okay. So now what I'm going to do is I'm going to create a further geometry here. Let me make a pocket at the center. So go to wireframe, create a pocket or a rectangular shape. Okay, make it at center. That's it. Or you can make it a roundabout. Okay, so I just make a roundabout here. Make the height 50 and the width is 150. Okay. And what I'm going to do is I'm going to create a slot here. Okay. Let me make it multi-line slot. Or either you can give it the length is 80. I'm going to make it 85. Now, once again, creating a new length here. And that's it. Now what I'm going to do is I'm going to create an offset of this line. Offset entity. Okay, on both sides, make it 5 millimeter each. Okay, that's it. And what I'm going to do is I'm going to remove this center entity. So just I'm making the channel here, okay? So use the trim option to trim the entity. And just use the same trim option to extend the entities. Okay, so go to solid, and what I'm going to do is I'm going to create a solid and select the this chain. Okay, now what I'm going to do is I'm going to make a pocket inside this solid. Let's make it 15 millimeter in depth. So this is not to create a body, just I want to create a cut body inside this. Okay. And now what I need is I want to join this to make a single chain. Click here. Here. And here. Okay. Now go to solid, extrude. Yes, this section. Okay, cut body. So just it also automatically creates a cut body. Okay. So what we did, we just create a simple body. This is a solid body. We're using the wireframe to create a simple 3D model here. And now what we're going to do is let me show you how we can make 3D toolpaths on this side. So this is a model having a 50 millimeter thickness and 100 millimeter in height, and the width is 300 millimeters. It's a block, and at the center we have a pocket, and it's have a roundabouts each. So, and here we have a L-shaped channel here. So what we're going to do is we need to create a pocket, and we have to create a channel here. So for that purpose, I need to go to machine option and select the milling machine. Because what we're going to do is we have to apply 3D toolpaths here. In the previous videos, we discussed all about the 2D toolpaths. And now in this video, I'm going to tell you how we can create 3D toolpaths using the MasterCAM. Okay, so here we have the optimize rough, we have the pocket, we have the project option here, parallel and plunge, multi-surface and rough area. So all these are the roughing parameters or roughing toolpaths. And in the finishing, we have the waterline finishing toolpath, raster machining toolpath, and scallop, equal scallop, and hybrid, pencil, blend, contour, horizontal area, scallop, project, flow line, spiral, and radial toolpaths. But for that, I have only the pocket area. So what I'm going to do is I'm just click on the pocket, and I'm going to select the surface which I want to machine. So I just want to machine this area. So I just select this area and click on the end selection. Yes. So it shows that we have the drive area which you want to machine, or area where the cutting tool will be worked is called the drive area. So I have selected the drive area, this. And the next thing we have this containment. So this area is where the cutting tool will perform its own operation, and the containment we call it the boundary. See, under this boundary, the cutting tool will work inside this pocket. So what I'm going to do is I'm going to select the containment. So this would be my boundary, and inside this boundary, the cutting tool will work. Okay. If you select the opposite side, it will work on the other side of the boundary and machine that area, but will never machine this area. Okay. So click OK, and then again OK. So now we have the 3D toolpath parameter area is open. You have to set different parameters here. First thing, we have the toolpath parameter. We have to select an appropriate cutting tool for this. So let me select an appropriate tool. Let me first filter the tool. So just click none, select the animal cutting tool, go to select library tool, and select any appropriate tool according to the geometry you want to create. So I'm going to select the 10 millimeter angle, which has the 4 fluted, and its length is 16 millimeter, and the die is 10 millimeter. Okay. So the spindle direction is clockwise. Spindle speed is, I'm going to make it 10,000 RPM. And the feed rate is 3,000. And the plunge rate is 500. So this is my tool number 1. So it will show that the tool is number 1. Want to use the coolant? Yes, I want to use the coolant. For the hard materials, you definitely need a coolant to cool down your workpiece and your cutter. And how about the surface parameter? So first we have did the toolpath parameter done. Okay, you don't need any further changing. Go to surface parameter, and here we have the links. So the clearance area is 50 millimeter. It's in an absolute position. After performing all operation, it will go back to its clearance position, which is 50 millimeter from the top surface. The next is the retract point. After each cutting toolpath, it will be retract to its position. So it shows that it's an incremental value. Let me make it to absolute. You can either check or uncheck this position. Okay. So for that, it's 25 millimeter retract point is okay. So you don't need to check the clearance curve unless you have to check whether there is no such obstacles on the work area. It's not, but it's a safety point. We should have to check this. Okay. And the retract point is 25. Okay. And how about the feed plane? The feed plane where the cutter will be enters into your cutting area. Feed plane is for. So let me set the feed plane is 2 millimeter height above the surface of the workpiece. And how about the tool containment? So you see that the cutter will be work inside this area, and we have the boundary here. So if it says that the center, it shows that the cutter will be half work outside and half work inside. So we don't want to work half outside and half inside. We want all our cutter to work inside this boundary. So we will select inside. Okay. So if you select this center and using the 10 millimeter and mill, the 5 millimeter will work outside and 5 millimeter will be inside the boundary. But if you select the inside, the whole cutter will be work inside this boundary. Okay. And if you select the outside, the cutter will be totally work outside of this boundary and machine all other area other than machine that area. Okay. So just select the inside. And if you want to leave any stock on the walls or inside, just write down the amount that will be removed. It will leave that area and will never machine that area. So we just want to remove all that material which we have selected. Now let's move towards the rough parameters. So rough parameters shows that the total tolerance you need to perform all the operations. So 0.025 is enough, but most of the time I'm using the 0.01 millimeter, the tolerance total. And how about the maximum step down? The step down means that how much cut it will take every time it enters into the workpiece. So it's 2 millimeters. It's too much cut for the 10 millimeter tool. So I just make it 0.5 millimeter. So I'm just giving you a general overview how we can create the 3D tool paths here. So this is just an introductory video to the module number 4. We'll discuss in depth in the next upcoming videos. So depth of cut is incremental, 0.2 millimeter. How about the gap setting? I just want to make the gap between each tool path smooth, not the rough, and set the optimized cutting cordon. And how about the pocket parameters? As you see that in the 2D toolpath, we have the pocket parameters and we have the style of cutting. So we have the zigzag method, constant, spiral, high-speed spiral, true spiral, and morph spiral. So most of the time we use the parallel, and amount of cutter being utilized is 75 millimeter, means 10 millimeter we have 7.5 millimeter cutter will be utilized during the machining device. Now let's go and create and generate the toolpath. Okay. So what you see that it creates the toolpath, and what you see over here is just not give any depth here. So what you need is you have to select the appropriate depth for the machine. We have only select this the surface, and just it creates only the toolpath on this surface. So we need to set the depth. For the depth setting, just go to parameters again and rough cutting parameter. Here we have the cut depths. So this is how about the incremental depth cut, but what we have, we using the absolute depth, and in the absolute depth, we have the minimum depth. So minimum depth, we have the top of the stop, which is 0 millimeter. And how about the maximum depth here? We don't know what is the maximum depth, so just go and select the depth here. Yes, I'm going to reset and just select any point here. Okay. Okay. So it's minus 15 millimeter. Okay. So we have the minus 15 millimeter from the top of the stock. Just click OK, and now click OK to generate the toolpath. So here what you see that it creates a toolpath of the 3D model and make a depth of 15 millimeter in depth to this pocket. So we take 0.5 millimeter depth cut, and it will down from top of the start, from top to bottom, minus 15 millimeter, and creates this pocket. So this is how we can create 3D toolpaths. Just give you an idea how we are going to perform 3D toolpaths for our 3D models. Okay. So now let's get and do another operation here, which is a channel here. Okay. So what we are going to do is we are going to create a operation here. So let's go and select the 3D option here, which is also in a pocket. Okay, I'm just going to select this surface. So we have selected this surface. Okay. And how about the containment? Well, this is what we have, the containment. So we want our tool to be working inside this channel. Okay. Okay. So this is 10 millimeter. Let me give the dimension here. What is the width of this channel? Go to draft and let's first cancel this. Go to smart dimension and we have the 10 millimeter width of the channel. So click cancel here. Go to parameters, and for that we have the 10 millimeter width, but the 10 millimeter cutter will not work around these edges. So for that purpose, what you need is you have to make it down. So our cutter should not be at 10 millimeter, but I'm going to select a cutter which is 5 millimeter in dia. Okay. So make it cutter 2 millimeter, named it 2. It's a second cutter, and make it the spindle speed same for the, and the parameter same. And how about the coolant on? Go to surface and make it inside. Okay, parameter same, and pocket style zigzag. So if we work like zigzag. And how about the depth of cut? It's automatically be 15 millimeter. Okay, just click. And what you see over here is all the working parameter would be in a C shape direction, like C shape line zigzag. Okay, so you can either change the direction of this by click on the parameter, pocket parameter, and give an angle to the, so this is a 0 degree angle. Just you can give an angle of 90 degree to make. Okay, so here you see that it's a zigzag, but you see here that the cutter is moving in a zigzag direction here. So you can either finish that area, make a quick zig, or you can make it in one-way direction, or as you want. Okay, and how about the jab setting? Make it smooth, make it to follow the surface, or broken, or just use the drag. Okay, so with finish pass, the tool may engage a large amount of material in the low pockets. Okay, so this is how the cutter will work, and it will never remove the finishing area. So this is just an overview how we can create 3D toolpaths for the 3D models in this module. Okay, so for more videos, stay tuned, and thank you very much.